Okay, so now that we've spent a lot of time graphing log functions and exponential functions, let's take some time going through this review sheet here. So probably you would have had me assign this in class. Here's a chance to be able to go through some of the solutions in a little more detail. So the domain of this, it's a log function. We know this 2x plus 5 is our argument, and it's defined when it's greater than 0. So that means that x will be greater than negative 5 over 2. We don't have to worry about a base for any other tricks there. If you have something like this, you don't need to graph the entire thing. You could just say, well, I know that 4 minus x has to be greater than 0. I could add x onto the other side, and I could say 4 is greater than x, and that would be an acceptable answer. If you chose instead to say 4 minus x is greater than 0, and you subtracted 4, then if you divided by a negative 1 to get rid of the negative sign, remember that switches the inequality, and you would say x is less than 4. That means the exact same thing. So both are good answers. Determine the equation of the asymptote for this question here. So this is an exponential function. So if you have an exponential function, again, you don't need to graph the entire thing. A basic exponential function looks like this with an asymptote at y equals 0. This subtract 7 tells us we're going to drop everything down 7. So we could say we have an asymptote at y equals negative 7. Determine the equation of the asymptote of this log function right here. Well, you know that x plus 6 is the part that has your restrictions. And if you make that equal to 0, that's where you could find your asymptote, and it'll be at the equation x equals negative 6. Determine the x-intercept of our function. Well, you could put in 0 for y, and let's solve for x. Let's add 4 onto the other side. So 4, let's do this over here, is equal to 2 log base 4 of x minus 1. Divide by 2, divide by 2. 2 is equal to log base 4 of x minus 1. 4 to the power of 2 equals x minus 1. 16 equals x minus 1. So x would be equal to 17. Meaning our x-intercept would be 17, 0. Determine the y-intercept. This is for question number 6. We could put in 0 for x. And if you do that, you would get y equals 6 subtract 5. You'd have a y-intercept at 1. Okay, first 6 questions were hopefully fairly standard. Question number 7 now gets a little bit more complicated. An exponential function is written in the form of y equals 4 to the power of x minus h plus k. Determine the exponential function that has a y-intercept of 13 and an asymptote of y equals negative 3. If we have a y-intercept of 13 and an asymptote of y equals negative 3, this part right here, that's going to be our k value because we'll have dropped 3 units. So we could say right away y equals 4 to the power of x minus h subtract 3. And if they give us the y-intercept of 13, they're telling us that we have the point 0, 13, and we could sub that in for x and y. So if we do something like that, it would be 13 equals 4 to the power of 0 minus h subtract 3. And we can now solve for h. So let's add 3 onto the other side. 16 equals 4 to the 0 minus h. Let's write 16 as a power of 4. 4 squared equals 4 to the negative h, which means that 2 equals negative h, which means that h equals negative 2. So if you go back to your very original part right here, you could rewrite what you have, and you could say it would be y equals 4 to the power of x, subtract negative 2, which is like saying x plus 2, subtract 3, and that would be your equation that satisfies all of those characteristics. Okay, I think we have 2 graph questions coming up here now. We have one exponential function, we got one log function. So our exponential function, let's graph y equals base 2 of x to begin with. Now, what transformations are happening here? We have a horizontal expansion by a factor of 2, and we're going 2 to the left and 1 up. So let's horizontally expand it by a factor of 2. So let's double our x values. And then based off of that, let's go 2 to the left and 1 up. Okay, so let me actually just do one more point here. Sorry, if this was at 3, there we go. Okay, and if we go 2 to the left and 1 up, then that would be our final answer right there. Now we have an asymptote at y equals 1, and we should put that in. And we know we have an asymptote at y equals 1 because we moved up 1. So our horizontal asymptote is at y equals 1. There is no vertical asymptote because it's an exponential function. And our domain is all real numbers because our domain is always all real numbers for exponential functions. Our range is greater than 1. Our x-intercept does not exist because we're staying above the x-axis where we have an asymptote at y equals 1 and everything's above there. And our y-intercept, you can clearly see it's at the point 0, 3. But if you want to solve for it algebraically, you could always put in 0 for x right here. And if you did put in 0 for x, you would be left with y equals 2 to the power of 1 plus 1, and you would get 3, which confirms what we had for a y-intercept. Okay, question number 9. This log function. Now we had a couple log functions. We did 4 examples in the last part, and I think they all had base 2s. So now we have a base of 3, which means that we need to know what y equals 3 to the x looks like. And if you graph a couple of those points, that may help. The other thing you could do is you could think of, well, what would your basic y equals log base 3 of x have points as? If you put in a 9 for an x, you would get a value of 2. If you put in a 3 for an x, you would get a value of 1. If you put in a 1 for an x, you would get a value of 0. And if you put in something like, I don't know, if you put in a third for an x, you would get negative 1. So you could do a full-on table of values, or you could say something like that. And we have our basic y equals log base 3 of x graph right there. But if you're not sure on that, or you're not feeling good about it, graph y equals 3 to the x to begin with, and then take the inverse to find those points. Now from here, they want us to reflect this over the x-axis, and then they want us to go 3 left and 4 up. So take a look at these key points, 1, 2, and let's reflect them over the x-axis. And then let's go 3 to the left and 4 up. One, two, three. 4. I think I did that first point off. Wait, 1, 2, 3, 2, 3, 4. There we go. 1, 2, 3, 1, 2, 3. One, two, three, 1, 2. Okay. And we get something that looks like that. Okay. All right, so this one will be exciting because I don't know what the x-intercept is going to be. Let's see what we can answer. Our domain is x is greater than -3. And that's because we have an asymptote here at -3. Our range will be all real numbers. We have a vertical asymptote at x equals -3, but we don't have a horizontal asymptote because it's a log function. Our y-intercept is at 0, 3. You could clearly check that out by putting in a 0 here, and you would get -1 plus 4, which would check out to be 3. But our x-intercept is going to be a little bit more challenging. So to find our x-intercept, we could put in 0 for y. We could subtract 4 into the other side. Divide both sides by -1. 4 is equal to log base 3 of x plus 3. Okay, so now we could say something like 3 to the 4 equals x plus 3. 81 equals x plus 3. X is equal to 78, and whoa, I can't believe that. But our x-intercept is going to be the point 78, 0. I guess that's what happens when you don't have a base 2 and you have something like a base 3. It really ramps up quickly. So if you were to carry this on, it actually wouldn't cross the x-axis until you got to an x value of 78. Okay, that was a short, quick practice quiz, quick sort of lesson preview. Lesson review. But that's how to be able to do questions for graphing logs and graphing exponential functions.